Alright, so now we're happy with our schematic. We're ready to lay it out on the board. And how do we get there? We don't need to go up here and file new schematic or whatever, or over on our control panel and do that. The easiest way is just to come up here and you see this SCH BRD button, and that will generate the board and allow you to switch back and forth between the two. So we're going to click on that. It's going to say, do you want a, there's not a board, do you want to make one? Yes. So we click that and this is going to come up. So over here is all our parts and here's our board. It will auto make the board to the maximum size of whatever version you're using. The freeware I think is only 8 square centimeters or something like that, but don't worry about it. It's going to be under that for sure. So the first thing we need to take care of is, much like in our schematic, we have our grid, and that's probably more important here than it is even in the schematic. So what we're going to do is click on that, and it's by default I think it's in mils, yeah. And I'm going to switch that to inches. Use whichever makes sense to you. You can use metric if you want. It's probably smarter, but I'm in the US and we don't roll that way for whatever reason. Default is 0.05 inches, and that's fine for just kind of getting a feel for what size and basic placement stuff. I typically like to start at 0.025, and just like on the schematic, if you right click that and do new, you can make that an alias so you don't have to go in and type in the size every time. I've already got that in here, and a couple other sizes. One note, it is by default an actual grid overlay is turned off. You can turn that off, and I kind of like having it on at the larger intervals, or whatever the right word is for larger grid. But when you zoom in, you can see that, and that's kind of just helpful to get, you know, symmetry right, or getting things placed along the straight line without having to guess. It's very helpful. Now if we look at all our components, they all have the name and the value, and that could be handy, but it's going to use up a lot of board space to have all this text, and it's just not super economical by default this way. This over here, the button up here at the top, is our layer settings, and it's very similar to the grid. We're just gonna go in and tell it what layers we want to actually have viewed, and there's a whole bunch on here, and most of them you don't really have to worry about. The main ones you need to think about are the top 10 or so. We don't really need, and right now we don't really need to show the values. T stands for the top and B is the back or bottom of the board. So we're going to turn those off, hit OK, and again you can save that as a preset here. Same way, hit new and type in what you want to call it. I call it no values. And there you go. From here, I typically delete the default board that's been given, and just grab the trash can icon, delete, 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 delete. If for whatever reason, let me shift gears real quick, your background here is white, and you don't want it to be white, if it's hard for you to see. I find the white background very hard to work on. Up here is options. Click on options and go to user interface, and that will bring up this, and you can click whichever one you want. You can even make it a special color if you want. I like to keep mine at black. It's just easier on the eyes, it's easier to see. So we have parts. Now we don't have a board. We need to make a board. How do we make a board? Don't go down here and hit the line tool, click on that, and come up here to your layers. This is similar to this, but it's going to tell the program what layer you want to be, in this case, drawing on. So we'll do that. For a board outline, you don't really need a width. It can be set to 0, and that's fine. All it's going to be doing is telling the fabricator where to cut things out, basically. If you're doing home fabrication, you're etching it, you could leave it at a little higher width, just to differentiate it when you print it out or whatever. If you're using a CNC mill, don't worry about it. We are going to do the right angle. This is how the line tool is going to work. Like if you turn, it'll do a 45, and that's selectable with this drop down. So for this, we want a right angle, just so we don't have to mess with 45s. What I like personally on my boards, and if you've bought any boards from me, you'll have seen all the edges of the board all the corners are rounded, and you can do that by selecting round meter wire, this over here, and then the radius of whatever you want. I usually do 1/10 of an inch, and this style. This is how your line appears. Is it a solid, a continuous line? Long dash, short dash, or dot dash, those are just different patterns. We want continuous, because otherwise it's just going to give us a weird dotted line around our board, which is it's probably going to mess up a fabricator. I've never tried it. I don't really want to. So now we need to ask ourselves a couple questions, like how big do we want this board? What type of enclosure are we planning on using? The way we can easily figure that out is this little cross right down here is our origin point. That is 0, 0 on the X and Y meter. As you can see up here, these numbers change based on where your cursor is. So right here at the origin, that's 0, 0. So first one is X and second one is Y. So height and width. If you know the interior dimensions of your enclosure, you can go ahead and start drawing this for that. But if you don't, and you don't feel like Googling that real fast, come back over to add part, click on that. It's very similar to the other side. You can't just add parts that you want connected to your circuit at this stage. You need to do that in the schematic, so it actually connects to things. But there are some reference tools in the library, such as enclosures, which just give you a footprint of what it could fit in and just show you sizing and stuff. These are pre-sized. Some of them are more precise than others. These are, again, from Brian's library. I've not had an issue with anything in here. There's a few things I've added, but I haven't had issues with those either. It'd be nice if this fit in a 1590B with just 2 pots there. So that gives us an outline of the enclosure. Those dotted lines around it, that's the sides, which is helpful when generating your drill template. Let's just throw this here. The dotted line on the inside here, that's really where you need to keep your board inside of that, and especially your pots as well, because that's the bottom of the top face. It may not make a lot of sense, but that's just keep it inside that. So not a bad idea to, well, let's draw the outline of our board. We still got that set up. I'm gonna start kind of in the middle. I'm gonna give myself a little extra space here on the sides, just to be safe. And this is by no means our final size. This will probably get adjusted. Once you've connected it, you just hit escape, and that will close the drawing. This will probably get massaged as we go along, but there really aren't that many components in this, so it should be doable. But just don't be afraid to adjust as you go along, and you can move this around, and then adjust it as you need to. I'm going to go ahead and place my pots, because that's the other thing. With this one, it's fairly straightforward, since it's just 2 pots and the external LED indicator. And remember, you are looking at the bottom side of your enclosure in this view, unless you're getting fancy with long pin pots or doing something a little extra. But generally speaking, this is how you're going to be working. So I'm going to place the volume on the right, which will be the left when you flip it over, and the gain on this side. If it is confusing, you see here that's got that looks like gobbledygook. That's kind of discernible. It says volume. This is showing on the back layer of the silk screen that's going to be on the back side of the board. The name is there as well. So if that's bothering you, you can go over to your visible layers and turn off back names, stop names, back names, 26. And now it's legible and doesn't give you a headache like it was just giving me. So where do we want to put our LED? Preferably somewhere symmetrical. Up here is not great because that would be where the DC jack probably will be, and there's no board right there either, so that's not helpful. Would probably put it about here, even with the lugs for the pot. I think I'm going to change this to a 3mm LED, and instead of switching back over to schematic, deleting this part and then adding another one, that's a whole hassle. What you can do very easily is find the wrench icon, which is change. You click on that, this pops up, and this allows you to change a whole host of stuff. Size, width, a whole bunch of stuff. We want to change the package, so we click package and then we click what we want to change. And I've got 5mm and 3mm. I want to change that to a 3mm, and there's our package for that, which has the pads a little closer together. It's a smaller footprint. You can still easily run a 5mm LED there, no problem. So that's where we're going to put it. And this is on the top layer of our silk screen, and we want this to be on the back because that's where it would be populated from. So I'm going to go to the mirror tool, which instead of just flipping it 180 degrees, it does flip it 180 degrees, just along the y-axis, I guess, instead of the whatever. It flips it to the back. So now, since we've turned off the names of the back layer, that is gone, and so that should be on the back silk screen, which, since there's no traces laid down yet, you're just seeing straight through. So let's put our LED there, and like I said, we'll probably design it for the DC jack to be up here at the top. So we should put our power pads somewhere along here as well. This is kind of in the way. Oh, and you know what? We should name this power. There we go. Or you could name it DC, whatever. Power is kind of cool. So again, this I would like this to be about in the same place as that LED, but it's not going to work. Fortunately, I have done this before, and again, we're going to change package, and I have this option, which allows me to put this on either side of the LED pads. And let's move this. A quick note, in old versions, I think mostly it was in 7. I think this changed with 8 and 9. I didn't use 8 a ton, but I did use 7 a lot. and I've used 9 a good bit since. Part names were fixed before, and you had to use like the smash button, I think is what it was called. You'd smash the part, and then the name would have the little gray X that you could then move. In 9, Eagle 9, they've made that everything is automatically smashed, and so you can just easily move part names around, and then actually I prefer that. It makes for a lot easier of a workflow. Okay, so we've got our power pads in, our LED placed. We need some traces on this thing, and if you're doing if you're approaching this to etch your own circuit boards, I suggest that you keep your pads fairly thick, because etching is not an exact science, and you'll have transfer lift, or just things can go wrong. So it's easier to have a little thicker trace. So if you do need to go back over it with a Sharpie or whatever, you don't have this tiny trace that you have to match with a pen. That way it just makes it for a little bit of a cleaner and easier etch. For this tutorial, we're going to be focusing on a dual layer board, and the one that will be for fabrication from a fab house like Osh Park or Elecrow or JLC. So the way I approach this step, I like to have ground planes, and that's even reflected in my etchable layouts on the blog. There's a big plane of copper, and then the traces are within that, and that plane is the ground plane. That's what everything connects to that goes to ground. I do the same thing for fabricated boards, but since we have 2 layers we can play with, I make the top layer the voltage rail, the 9 volts or whatever. So the way we do a plane, first we need to tell it what layer we want it to be on, and we're going to start with the bottom layer. That's going to be our ground layer. Now we're going to go over here into our tools and look at polygon, and this is going to allow us to draw basically a shape, whatever we want. It's similar to the line in that we have how the wire bends, and our width, and we have a couple other things though, like this is, do we want the plane to be solid? Do we want it to have a hatched pattern or inverted? That's a cutout. Everything else outside of that, whole bunch of options. For this, we're just going to keep it solid. Width is going to be it can be anything above 0.01. We also need to isolate this. That means any traces we run, the plane will automatically isolate those traces by a fixed amount. In this case, we're going to do 0.01 again, and that should be good. We can turn this off. This is left over from when we were drawing the outline of the board, so we can turn that to 0 just to keep things a little easier. Also, you will notice that our origin is 2 blocks away from the edge of our board. So before we draw our plane, I need to fix that for my own OCD. We're just going to select everything we've placed so far, zoom in, right click, move group, and we're gonna, there we go. That keeps our origin, the edge of the board at 0. It just keeps things a little neater. At this point, I'm going to go ahead and delete our enclosure just to make it a little easier to see. And I'm going to draw our ground plane now. Start at the origin and work your way around. And there. Now it's going to ask you, what do you want to call this? And we're going to call it GND because that's what we've named ground in our schematic. All these are now going to connect automatically to this plane once we have them placed inside that plane. In this case, volume lug 1 is going to go to ground, and so does this. That's the negative for power. So how come it's just a dotted rectangle at this point? Well, come over here to the rat's nest button, click that, and you can see, oh, we've got a cross through these pads that are connected, and that means they are automatically connected. We don't have to route traces to them, which makes life a little easier. Now we need to do the same thing on the top layer. Grab a polygon and do the same. And we're going to call this plus 9V because that's what we've called this, everything that connects to 9V. And then again, well, nothing we have on the board is connected to that yet, so hitting rat's nest isn't going to do anything. But we can go ahead and place our polarity protection diode, which in this case is D4. That connects there, and if we hit rat nest, there, everything's connected. Well, that's connected, not everything, but the one thing that is on the inside the board area that would connect to 9V, or what we've named 9V, is not connected, and you can see one thing. You can see there's a pretty hefty gap around the edge. This is how big that gap is going to be dependent on which fabricator you're going to use. Most fabricators will put up files that are called design rule files that you can download, and you can put into Eagle in this, again, in your documents folder in Eagle and design rules. There's a couple that I have that I use for various projects from various vendors. Copy those in there, and then you can come over here to DRC, that's design rule check. Click that, and it will ask you, right now it's using the Eagle default design rules. And it's best at this point, I think, to go ahead and run this so that you know how much gap between the edge of the board and the edge of the copper that your fabrication house is going to use. For this, I'm probably going to get it manufactured by Elecrow, so I'm going to use their DRC file, and I'll link that in the description. Click open and then check, and it says, oh, you've got 68 air wires, and that's what these yellow things are. It shows the connections within the circuit. And yeah, of course, there's going to be a whole bunch of unconnected things. We've barely got anything on our board. That's okay, just hit X. But now, when we hit rat's nest, ooh, that gap got a little smaller, and that can show you where you can place parts and still have, like if we put a resistor close over here on the edge, and then hit rat's nest, it'll show, okay, we can still get signal around the edge. You know, if we put it a little closer, will it? Yes, very thin, but it would still go around. So that's just a trick that I do just so I know and get a better idea of where I can place things.